Alright, so here we have a bucket full of water. It's revolved in a vertical circle of radius 2 meters. And the question asks, what should be the maximum time period, capital T. T in this case represents the period of time of revolution so that the water doesn't fall off the bucket. Okay. Alright, so let's go ahead and do this. So here's the diagram. There's a hand being or swinging a bucket of water in a vertical circle as stated. And it wants us to find the time period, maximum period, so it doesn't fall off. So the first function I want to start off here is with the speed function for an object being rotated in a circle at, well, in this case, hopefully a constant rate. It doesn't say so, but we can figure it out. Okay, so here v is equal to 2 pi r divided by capital T. Once again, capital T in this case, in this statement here, represents the time period. 2 pi r represents the circumference of the circle. So here, in order to find t, I want to go ahead and switch t and v. Multiply both sides by t, but at the same time divide both sides by v. Or you can just do a little switcheroo. In here, t is equal to 2 pi r divided by v. Okay. Here, well, 2 and pi are just constants. R is given as 2 meters. And the only thing I don't know is v. So I got to set up the centripetal force stuff to find v. Okay. But I do want to point out that if, in order for you to find the time period, needed for the water not to fall out of the bucket, you should definitely draw your free body diagram here. So here are at the very top of the vertical circle, here's f of g, and because it's tied to a string, here is the tension in the string, typically at the very top. All right. However, if I were to set up the centripetal force, for the bucket at the top of the water, at the top of the vertical circle here, because the only place that it can fall out essentially here is at the top, right? It's trying to find the maximum time period for this not to happen, implying at the top of the circle. Well, here, f of c typically at the very top of the circle is f of g plus t because both of these vectors are pointing down the page. However, based on the wording, it says maximum time period. I made a statement here for you to hopefully conceptually understand this stuff. Well, maximum time period, I said more time would equal slower speed. Hence, if it's slower speed, really you need v min at the very, very top. Okay, what is this minimum speed that it has to be swung by in order for this phenomenon not to occur? All right, so therefore, maximum time period, aka more time, would equal slower speed, because if you travel slower, you take more time to complete a circle. Okay, well, that's important because on the right side here, I can cancel out t out. Now, why do we want to cancel t out? Because I'm looking for a slow speed. In this case, I need to find v min. V min because I need to find slow speed, okay? Or slower speed. All right, but if I'm going to cross t out here, because this condition is given, maximum time period, in my free body diagram, I'm going to go ahead and visually erase t. You cannot erase f of g. So therefore, f of c is now just f of g, okay? Well, we can break this stuff into mv squared over r. F of g is just mass times gravity, cancel out masses, and then we need to find v. Once again, setting this left side of the work here, you know 2, you know pi, you know r is 2. The only thing you're missing is v. So by doing this work with centripetal force, you're really trying to find the minimum speed needed at the top in order for the water not to fall out. So to get v squared by itself, I multiply both sides by r, and then I'll go ahead and plug values in. Okay, I know g is 9.8. I know r is 2 because it's given. And then I want to multiply that. 9.8 times 2 is 19.6. And then I'm going to square root 19.6. And that'll give us a v min of 4.43. Okay, so it's important that as you calculate this stuff, you know what this represents. V here is the minimum speed needed for the bucket to go at the top in order for the water not to fall out. Well, now that I know v min, right, well, I can plug it back into my time function. Okay, so here, capital T, once again in this function, represents the time period, not tension. So I know 2 pi, I know r, now I know v. So I just substitute it into, I carry down 2 pi, I substitute in for r, which is 2 meters, and then v here is 4.43 meters per second I just calculated. If you simplify this on your calculator, the numerator becomes 12.57, and then the denominator stays the same, 4.43, and if you punch on your calculator, you get a time period of about 2.84 seconds, and that is your answer. Okay, so These statements are super important, so hopefully as you practice, you understand what it implies and what it suggests that you do. So in this case, maximum time period suggests it is moving at a lower speed. Lower speed implied the tension in the string is 0. That is the only way to find V minimum, and therefore once you find V minimum, it allows you to find the period. All right, stay nerdy, don't be whack.